Hi, welcome to IGCSE and A-level chemistry classes. In this video, we are going to discuss about periodic table. Periodic table. See this figure, this is periodic table. Here we can see different elements. Here hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, etc. These are different elements. These are the elements. These elements are arranged according to their atomic number, according to their increasing order of atomic number. And here in periodic table we can see horizontal rows and vertical column. Horizontal rows are called periods and vertical columns are called group. Okay. This is modern periodic table. In modern periodic table, we can see around 118 elements. There are 118 elements in modern periodic table. So, in periodic table, we can see period and group. Horizontal rows are called period and vertical columns are called group. Okay, and in periodic table, elements are arranged according to their atomic number, according to their increasing order of atomic number. Next one, in periodic table, we can see three different type of elements: metals, non-metals and metalloid. Metals such as aluminum, gold, sodium, potassium, calcium, magnesium, these are metals. And another one, non-metals. Non-metals such as nitrogen, oxygen, fluorine, chlorine, neon, argon, these are non-metals. Another category, metalloid. Metalloid mean boron, silicon, germanium, these are metalloid. Okay, so in periodic table there are three different type of elements: metals, non-metals and metalloid. In periodic table, left side you can see metals and right side you can see non-metals. Metals and non-metals are separated by metalloid. Metals and non-metals are separating by metalloid. Next one, we had to discuss here valency. Valency means combining power of an element called valency. Combining power of an element called valency. Okay, valency and group number related. Here, look here in this periodic table you can see group number 1, 2, after 1, 2, 3, 4, 5, 6, 7, 8. These are group number. Okay. Group 1 to 4, group number 1 to 4, their valency and group number same. Valency and group number same from 1 to 4. Okay. Group number 8, group number 5 to 8, their valency will be 8 minus n. 8 minus n. Okay. N mean their group number. For example, nitrogen. Nitrogen which group? Nitrogen group 5. Group 5. So valency will be, valency of nitrogen 8 minus n. 8 minus 5. Group number 5. 8 minus 5. So valency will be 3. Similarly, look here, noble gases, group number 8. Noble gases, helium, neon, argon, krypton, xenon. So their valency will be 8 minus n. N mean group number, 8 minus 8. So valency will be 0. Okay, this is valency. Valency and group number. Next one, trend in properties. Different trend in properties. Look here, we already discussed group and period. group and period. Also we discuss in periodic table, left side it is metal, right side it is non-metal. Okay. Metallic character decreases from left to right in periodic table. In periodic table, when you move from left side to right side, metallic character decreases. For example, lithium, um, beryllium, boron, carbon, nitrogen. When you move from left to right in periodic table, you can see left side it is metal, right side it is non-metal, between it is metalloid. It's mean metallic character decreasing from left side to right side. Okay, and when you move down the group, group, vertical column it is group. When you are moving from top to down in a group, in case of metal, metallic character increases. Metallic character increases. Also reactivity of metals increases. When you moving from top to down in a group, in case of metal, left side, reactivity of metals increases. But in right hand side, we know it is non-metal. When you are moving from top to down, reactivity of non-metals decreases. In case of metal, reactivity increases. In case of non-metal, reactivity decreases. So first group, look here, group 1, lithium, sodium, potassium, rubidium, cesium, francium. Okay, so reactivity increasing. When you consider lithium, sodium, potassium, which metal more reactive? Potassium is more reactive. But right hand side, see group 17, fluorine, chlorine, bromine, iodine. Group 17. So when you are moving from top to down, reactivity decreases. Which element most reactive in group 17? Fluorine is most reactive. Look here, in case of metal, reactivity increases from top to down. Okay, why reactivity increasing from top to down in group? Here, when when you moving from top to down, size of the metal increases. Size of the metal increasing. Okay, when you are moving from top to down, atomic number increasing, number of shells increasing. So distance between nucleus and outer shell electron increases. Distance increases. Less attraction between nucleus and outer shell electron. So outer shell electron can lose very easily, and therefore metals are highly reactive. When you are moving from top to down, size of the atom increasing, atomic size increases, atomic radius increases. That's why distance between nucleus and outer shell electron increases. So less attraction between nucleus and outer shell electron. So outer shell electron can lose very easily. Okay, this is the reason reactivity of metal increasing from top to down. Okay. But in case of non-metals receive electron, not losing electron. Non-metals receive electron during chemical reaction. When you are moving from top to down in non-metal, size of non-metal increases. Distance between nucleus and outer shell electron increases. Okay, so nucleus cannot accept another electron very easily when the size of atom increases. That's why reactivity of non-metal decreasing from top to down. Okay, when you are moving from top to down, size of non-metals increases, so nucleus cannot accept extra electron easily. Next one, we have to discuss here alkali metals. Alkali metals. In periodic table, group 1 elements are called alkali metals. Lithium, sodium, potassium, rubidium, cesium, francium. These are alkali metal. Lithium, sodium, potassium, rubidium, cesium, francium. Here francium is radioactive element and cesium is the most reactive metal in group 1. We already discussed when you moving from top to down in a group, reactivity increases. Next one, we have to discuss here chemical properties of alkali metals. Chemical properties of alkali metals. Here alkali metals forms ionic compounds. These are highly reactive metal. These metals react with the non-metals and form ionic compound. Similarly, alkali metals, it react with halogens such as chlorine, bromine, iodine and form colorless compounds. Alkali metal reacted with halogens form colorless compounds. For example, sodium chloride. Sodium reacted with chlorine. It formed sodium chloride colorless compound. Alkali metals are highly reactive. Even it react with cold water vigorously and form hydrogen gas. Alkali metal react with cold water vigorously and form hydrogen gas. For example, sodium reacted with water, sodium hydroxide. Potassium reacted with water, potassium hydroxide. Okay, alkali metal reacted with water, it formed alkaline solution. Okay, group 1 metal reacted with water, it formed alkaline solution. Their pH more than 7. That's why these group elements are called alkali metals. Flame test or this group 1 metals after burn in non-luminous flame, it produce different colors. For example, lithium after burn, it produce red color. Sodium produce yellow color. Potassium produce lilac. Okay, this group 1 elements after burning, it producing different colors in flame. Lithium red color, sodium yellow, potassium lilac. So physical properties of group 1 elements. Here group 1 elements, these are alkali metals. They form ionic compounds. They react with the halogens and they react vigorously with the cold water because they are highly reactive elements. They produce colors in flame. Lithium red, sodium yellow, potassium lilac. Next one, physical properties of group 1 elements. Group 1 elements, we know all of them are metals. That's why they are good conductor of heat and electricity. But compared to other metals, group 1 alkali metals are soft metals. They have low density. Okay, they have low density. They are soft metals. Okay, but they are good conductor of heat and electricity. Also, these metals, they have low melting and boiling point compared to other metals such as iron, gold, silver, aluminium. These metals have low melting and boiling point. Okay. Next one here, patterns of the properties. In group 1, when you are moving from top to down, size of the elements increases. We discussed already before, reactivity, density, size of the elements increases from top to down, but melting and boiling point decreases. Melting point and boiling point of the elements decreasing. Reactivity, size, density, everything increasing from top to down. Okay, these are the things you have to remember in group 1 elements. Next one, we have to discuss here halogens. Halogens. In periodic table, group 7 elements are called halogens. Fluorine, chlorine, bromine, iodine, astatine, these are halogens. In halogens, fluorine and chlorine are gaseous state, bromine liquid state, iodine and astatine are solid state. Okay, these are the colored elements. Here fluorine it is pale yellow, chlorine yellow green, bromine red brown, iodine black solid, astatine also black solid. Okay, and group 7 elements are halogen. They are poisonous gases. They do not conduct electricity. Also, these elements are diatomic in nature. Diatomic in nature mean these elements exist in the nature in the form of F2, Cl2, Br2, I2 like this. Okay, in covalent bond two elements combine together, they exist like this. That's why we say they are diatomic in nature. So here we discuss halogens. Halogens are fluorine, chlorine, bromine, iodine, astatine. Fluorine, chlorine it is gaseous state, bromine liquid state, iodine and astatine are solid state. Okay, and they are colored elements. They are poisonous. They do not conduct electricity. They are diatomic in nature. Fluorine pale yellow, chlorine yellow green, bromine red brown, iodine and astatine are black. Next one, patterns in their properties. When you are moving from top to down, means when you are moving from fluorine to astatine, when you are moving fluorine, chlorine, bromine, iodine, astatine from top to down in the group 7, the size of the elements increases. Of course, number of shells increasing, size of the atom increases. Also look, I told you before, pale yellow, yellow green, red brown, black black. Okay, their color. So darkness of the elements increases, melting and boiling point increases, reactivity decreases. Here group 7 it is non-metals. That's why when you are moving from top to down, reactivity decreases. I told you before, in case of metal, when you moving from top to down, reactivity increases. Okay, but non-metals, when you are moving from top to down, reactivity decreases, not increasing, reactivity decreases, but their density, hardness, melting and boiling point increasing, only reactivity decreases. But group 1, alkali metals, group 1, we discussed already group 1. In group 1, reactivity increasing, size of the elements increases, but their melting and boiling point decreases. Melting and boiling point decreasing, but their size increases, reactivity increases. Okay, softness increases, only melting and boiling point decreases in group 1. So we discussed here halogens, group 7. Group 7 elements are halogens, fluorine, chlorine, bromine, iodine. Okay, they are poisonous elements and they do not conduct electricity. They are diatomic in nature. Okay, when we moving from top to down, size, darkness, melting and boiling point increasing, but reactivity decreases. Okay, next one we have to discuss here transition metals. D block elements in periodic table, D block elements are called transition metals, transition elements. Here most of them are metals in transition elements. They are metals. Okay, and they are solid state except mercury. In transition elements, except mercury, all other elements are solid state at room temperature. Mercury, Hg, It is liquid state. And these elements, transition metals, have high melting and boiling point. They are good conductor of electricity. Okay. Silver is the best conductor of electricity. Silver. Silver symbol is Ag. And transition metals make colored compounds. Transition elements are colorless, but they make colored compounds. For example, aqueous copper sulfate. Aqueous copper sulfate, it is blue color. Potassium permanganate, aqueous potassium permanganate, purple color. Aqueous potassium dichromate, orange color. So here potassium permanganate, here transition metals, they make colored compounds. Transition elements are colorless. And the next one, here transition metals, they used as catalyst. Transition metals or their compound used as catalyst. For example, Haber process. In Haber process, iron powder used as catalyst. Haber process means production of ammonia. Production of ammonia from nitrogen and hydrogen. This process is called Haber process. In Haber process, iron powder used as catalyst. Next one, another example, contact process. Contact process means production of sulfuric acid. In production of sulfuric acid, vanadium oxide V2O5, vanadium pentoxide or vanadium oxide used as catalyst. And transition metals are malleable and ductile. Transition metals are malleable and ductile. The most malleable and ductile metal is gold. Gold is the most malleable and ductile element. And here another point related to transition metal. Transition metal shows variable oxidation state. Variable oxidation state. For example, iron Fe2 plus. Iron showing Fe2 plus and Fe3 plus. Cobalt CO2 plus and CO3 plus. These are the variable oxidation state. Variable oxidation state means one element showing different charges. So here we discussed transition metal. Transition metals are D block elements. Most of the transition elements are metals and solid state. Okay, except mercury. Mercury, it is liquid state at room temperature. These elements have high melting and boiling point. They are good conductor of electricity. They make colored compounds. They are colorless, but they make colored compound. Okay, and transition metals or their compound used as catalyst. And transition metals are malleable and ductile. They form variable oxidation state. Okay, Fe2 plus, Fe3 plus, cobalt 2 plus, cobalt 3 plus. Example. Next one, we have to discuss here noble gases. In periodic table, group 8 elements are called noble gases. Noble gases also called inert gases. Helium, neon, argon, krypton, xenon, radon. These are noble gases. Okay, noble gases calling inert gases because these elements do not involve any type of chemical reaction. They have stable electronic configuration. That's why they do not take part any type of chemical reaction. That's why noble gases are called inert gases. When we moving from top to down in group 8 element, their density increases, melting and boiling point increases, density also increases. And another point, noble gases are poor conductor of electricity. Different uses of noble gases. Here, helium used to fill weather balloon. helium, it is very low density and less reactive. That's why helium used to fill in weather balloons. Argon also unreactive gas. All these noble gases are unreactive, okay. Argon used to fill in filament bulb. Argon gas, it used to fill in filament bulb. Why? Argon, it is unreactive, so there is no any chemical reactions inside the bulb and the filament will stay longer time, okay. And uses of neon. Neon, it used in advertising light. Neon bulbs produce a red light. That's why it used in advertising light. These are the different points you have to learn. You have to learn in periodic table. Thank you for watching this channel. Please subscribe and press the bell icon for more videos. Thank you.